Hello class, today we're going to cover section 6.2, the parabola. A parabola is a collection of all points P in a plane that are the same distance d from a fixed point F as they are from a fixed line D. That point F is called the focus of the parabola, and that line D is called the directrix. And the result that we end up getting is that the distance from the focus to the point is the same as the distance from the point to the directrix. And so what's being really communicated here is this. This distance here from the point to the focus is the same distance as the point to the directrix. That's all that's really saying, and that's what a parabola really is. Now, the distance that we have from the focus to the vertex, that distance is a distance of A away. The distance from focus to directrix is 2A. And then we have a formula, there's a theorem that's given to us that tells us that the equation for a parabola with a vertex at 0, 0 and a focus of A is going to be y squared is equal to 4ax, and the directrix is going to occur at x equals negative a. So let's look at an example real quick, and it should be fairly straightforward. So we see that the focus occurs at a comma 0, and so the focus for our problem is 3, 0, and so we know that a is going to be equal to 3. That's really, really helpful. Our vertex is again at 0, 0, and so we're going to use that formula. Y squared is equal to 4ax, but we know what a is, and so 4 times 3 times x is going to give us y squared is equal to 12x. This is going to give us the equation to our parabola. So this is the equation to the parabola. And what we can do is we can actually plug in our value at the focus to be able to find 2 points on the parabola. And so if we do that, we could go y squared is equal to 12 times 3, because the focus occurs at 3. And we know that the focus isn't on the parabola. So y squared is equal to 36. So y is equal to plus or minus 6. And so we can go ahead and plot that. Oh, and one of the cool things is we also know that the directrix for this guy, I almost didn't write that, is going to be x equal to negative a. So when we go to use all that information, we'll graph it right here. We know that the focus was at 3, 0. Here's the x-axis. Here's the y-axis. We know that the origin is the vertex, and we know that the directrix, and I'll do it in a different color, is going to occur at negative 3, and it's just a straight line. It's a straight line. Bear with me. Right there, and that's going to be at x is equal negative 3. And then if we use those points that we had, so we found that at when x was 3, we got plus or minus 6, so we have these 2 points that are actually going to be on our parabola. So this is a point, and this is a point, and so we can graph this parabola to look like this. So that's just a quick sketch of how to do a parabola using the information that's given. Let's do another one. So here we're given a little bit of different information. But we've got to remember that y squared is equal to 4ax. And so since we have 8x, we know that 4a is equal to 8. So that tells me that a is equal to 2. So that's very, very helpful. Since a is equal to 2, my focus is going to occur at 2, 0. And I know that the directrix then is going to occur at x is equal to a negative 2. So let me start writing that information so that I have it. And so at 2, 0 is my focus. The origin again is the vertex, and then at negative 2 we have our directrix. So x equals negative 2. We're going to use the focus to find some points on this thing. So if we do that, we're going to get y squared is equal to 8 times 2. And so y squared is equal to 16. So y is equal to plus or minus the square root of 16, or y is equal to plus or minus 4. So the points that we're given are 2, 4 and 2, negative 4. So 2, 4 and 2, negative 4. And so when I collect and connect these points, this is the parabola. Now, so far the parabolas that we've looked at have opened to the right or to the left. Both that we've opened have opened to the right. And the reason that they open to the right is because my 4a was positive, or a was positive. If a is negative, if 4a is positive, it's going to open to the right. If 4a is negative, it's going to open to the left. And here's just examples of that. Now, that's for y equals x squared. But notice these last two here, and I'm talking about these two, x squared, when it's x squared, equals to 4ay or negative 4ay, it's going to either open up or down. And so this is just a table for you to look at, to reference, so you guys are able to look at these graphs. And then here's a little bit further addressing what that looks like. These are the graphs that you end up resulting with. So my a is positive, my 4a is positive for this example A, it opens to the right. For B, you can see the 4a has a negative value, so it opens to the left. When x squared is equal to 4a on the y, it opens up, and then when x squared is equal to a negative 4ay, it opens down. And so those are the 4 examples or demonstrations of what it's going to look like, just breaking down this chart in terms of a picture. So let me go ahead and use that information to graph another example for you. And so what we're going to get is, we get the focus is at 0, 4. So if that's the focus, I already know that this thing's going to open up, because notice the focus is always, since we know the vertex is at the origin, if that's the origin and the focus is above it, the focus is always in the middle of the parabola, and so we know it's going to open up. Okay. Now from here, using this information, we also know that the directrix is at negative 4a, or y is equal to negative 4, and so that's what our directrix is going to be. And then we can actually use our formula, so we know it's going to be x squared is equal to a positive 4ay. And because the focus is at 4, we know that a is 4, and so that tells us that a is 4. And so x squared is equal to 4 times 4y. So x squared is equal to 16y, which is very useful. And so what we end up seeing here is, since we know that the focus is 4, we can plug in 4 into our problem. And so we're going to get x squared is equal to 16 times 4. again, using the focus as something that's going to be useful. And so x squared is going to be equal to 64. And so x is equal to plus or minus the square root of 64. So x is equal to plus or minus 8. And so the points that we're going to have are going to be 8 comma 4 and 8 comma negative 4. And so 8 comma 4 is right here, and 8 comma negative 4. I'm sorry, I wrote it's going to be 4 both times. It's going to be a negative 8. That's going to be over here. And so my parabola, just like I said, opens up. And there's the picture of it. Now notice that the focus is also where the axis of symmetry occurs. I want to make sure I point that out. That is the axis of symmetry. And the focus always has the axis of symmetry going through it. Now, so far all of the equations that we've done or graphed have been going through the origin. But what happens if we're not at the origin? And this is it. This is the table for you to look at. So if our vertex is at HK, we see that there's going to be some shifts. And here's the breakdown of it. You can go ahead and pause if you'd like to write this down. But this is what it's going to be. And then here is some pictures of what the shifts do and look like. And again, like I said, if you want to go ahead and pause this and look at writing these down, by all means, go ahead. Let me use this information to go ahead and do an example for you. And here is my problem. And so in this problem, the vertex is at negative 2, 3. So that's my H, that's my K. And so I know that I'm going to get a focus at 0, 3. So let me just plot these points so I can see if I can get an idea. And so negative 2, 3. So if this is the x-axis, this is the y-axis. Negative 2, 3 is right here. And it tells me that the focus is at 0, 3. So if that's the focus, this thing's opening to the right. And so I know that this is going to be of the form, it's going to be like this form right here, right? So I'm going to go y minus 3 squared, and the 3 that I got is from right here, is equal to 4 times a x minus a negative 2, and the negative 2 I got from right here. And so what we need to do is we need to find out what a is. And we have to remember that a is the distance from the vertex to the focus. And so how far is this? So isn't that distance 2? So we know that we're going to have y minus 3 squared is equal to 4 times 2 x plus 2. So y minus 3 squared is going to be equal to 8x plus 2. That is the equation for the parabola. And then we could plug in the point 0 for x and find our two values for our y. Another thing that I didn't jot down is 2 away from it on this side should be then the directrix, right? Because it's a distance of 2 away on the other side. And so the directrix is at x is equal to a negative 4, because this distance is also a distance of 2 from the vertex of the parabola. So if we're going to use the point of the focus for x of 0, don't we get y minus 3 squared is equal to 8, 0 plus 2. So y minus 3 squared is equal to 16. So y minus 3 is going to be equal to plus or minus 4. So y is equal to plus 4 or a positive 4 plus 3, or y is equal to a positive 4, a negative 4 plus 3. So y is either going to be 7 or y will be negative 1 along the y-axis. So it'll be 7 or negative 1. And so the parabola looks like this. And that's the breakdown for it. Again, what I did is I used the focus and I plugged in for x to find my y values. Because in this case, I needed to find my y values. I knew that x was going to be, I knew x was 0, so I needed to find out what my y values would be to be able to find this thing. All right, let me do one more example for you. And this example is attacking it a little bit different way. And so we don't have anything clearly defined in this. So what I'm going to do is I'm going to go x squared plus 4x is equal to 4y. And then I'm going to complete the square. And so x squared plus 4x plus 4 is equal to 4y plus 4, because if I add 4 to one side, I have to add 4 to the other. And again, by completing the square, what I did was I took my b value, and my b value here is 4, and I went 4 divided by 2 and then squared it, which gave me 4. And that's how we complete the square. So I had to add 4 to both sides. So this ends up factoring to x plus 2 squared is equal to, and over here what I'm going to do is I'm going to factor out of 4. So I'm going to get this value. And so from here we have an equation, and this is the equation that we want to use. This is the equation of our parabola, but we can find some things, right? The vertex is going to occur at -2, -1. We know that it opens up. It opens up because my 4a is positive. So 4a is positive, and a happens to be 1. So from here, what I can do is I can go ahead and graph it. I'll do it right here. And so my vertex occurring at -2, -1. My focus being just 1 away from the vertex is at that point -2, 0, and I can plug in a value. So what I'm going to do is I'm going to plug in x is 0 and see what I get, because we have to remember, and I should actually provide you with the 1 away on the bottom. That is the directrix, and so the directrix is at x is equal to -2. And so I'm going to plug in 0 for x. So I'm going to go 0 plus 2 squared is equal to 4 times the quantity y plus 1. So I'm going to get 4 is equal to 4y plus 1. And that's going to give me 1 is equal to y plus 1, so y is equal to 0. So this value is going to be 0, and since we have an axis of symmetry, I'm going to use that bit of information. That's 2 away from the focus, so this should be 2 away from the focus, and so my parabola looks just like this. All right, I hope you found this beneficial. Please let me know if you have any questions. As always, all the best.